Good morning, good afternoon, and welcome to Smartlogic's webinar, Semantic AI-Powered Text Analytics Accelerate Business Outcomes. My name is Ann Kelly. I work in marketing communications here at Smartlogic, and I'll be your host today. I have two great speakers with me, Tom Reamy from the KAPS Group, actually the owner from the KAPS Group and a partner of Smartlogic. Tom has been in the text analytics business for a lot of years and knows a lot. He is the chairperson of the Text Analytics Forum Conference, and he's the author of Deep Text. Our second speaker is a Smartlogic staff member, Bob St Clair. He's the Global Information Science Services Leadership here. Bob has had a long career as well, but I like to think of Bob as the classification expert here at Smartlogic. That's how I was first introduced to him. A few housekeeping items before we get started, before I turn it over to the speakers. This webinar is in broadcast mode, so all of you are muted. If you have questions throughout the webinar, please put them in the GoToWebinar panel that you see at the right-hand side of your screen. We have about 40 to 45 minutes worth of content today, and then we'll open it up for Q&A at the end. We'll try to get to as many questions as we can. And finally, this broadcast is being recorded, and everyone who's registered for the webinar will get playback information. And when you get that playback information, I encourage you to share it with your coworkers, your colleagues, your friends, your family, and anyone else who you think would be interested in our topic today. And with that, I'm going to turn it over to Tom.
Okay, thanks, Ann. What we're going to cover today is a number of topics, and so we're going to sort of jump right in. We've done the introduction. I'm going to start off talking just a couple slides about what is text analytics and its potential, just because there's still some confusion. But I'm going to spend almost the entire time, my time, on talking about a unique approach that we've developed using two really key ideas. We're going to dive deeply into both of those, and then turn it over to Bob to talk about Semantic AI. As Ann mentioned, we're going to try to leave about 15 minutes for questions at the end. So let's jump in. If anybody that has seen my book on text analytics knows I'm not particularly fond of complex definitions of fields, particularly one as emerging as text analytics. But I wanted to just talk about it a little bit because the sort of main confusion probably is between text mining and text analytics. And for example, Wikipedia talks about them being basically synonymous. But then when you actually read the articles, the article on text mining is filled with mathematics and pattern recognition and so forth. And the article on text analytics is all about auto-categorization and language and concepts. So even when they're saying they're synonyms, they're not. And the way I look at it, text mining is one technique within the field of text analytics. And so the broadest definition is just simply text analytics is the use of semantic software and semantic models to analyze text. There's lots of different kinds of software, lots of different kinds of models, and lots of different applications you can do. But there's really two key functions in text analytics. Number one, auto-categorization. The second one being data extraction. So there's, again, different methods to do these, but these are the two key functions within text analytics. Sentiment analysis is often listed as a third, but in my world, sentiment analysis is just a special case of auto-categorization using sentiment concepts rather than subject concepts. So those are the two key functions. We're going to focus mostly on categorization today. But the idea behind text analytics is it's the technique, it's the technology and the techniques to turn unstructured text, this giant information overload that we all have to deal with, from a problem into a powerful resource. And that's what text analytics really is all about. And once you build these kinds build on top of these functions, you can build all sorts of different applications. So the applications, just a brief, I'd say there's an almost unlimited number. Some of the most important ones are improving search. Enterprise search, probably do some word association with enterprise search, and still the most common word is it sucks. But using text analytics, you can actually turn search into a really much more powerful application. It can improve search by orders of magnitude, both in terms of the accuracy, the amount of time people have to spend looking. Second really big area for text analytics is social media applications, customer and competitive intelligence. You want to know what customers are saying about your product, about your new initiative, and your new program, and you want to keep track of competitors. Well, analyzing social media text is one way of doing that. In addition, KM is another area. You can use text analytics for knowledge sharing. One of the big applications is often expertise location. In fact, one of the first projects that I ever did in text analytics, which I think was back in 2006, was an automated expertise location application. The problem with expertise location is that people have to write up their profiles, and they don't like to do that, and they don't necessarily do a very good job of it. So what we did was we created automatic profiles based on the documents that they'd written. So another area is business intelligence. Again, enhancing collaboration. One of the big areas is detecting fraud. For example, we did a project looking at the Enron emails, which of course are filled with fraud. And there's a number of different aspects of emails that contain lies that you can use to differentiate them from emails that don't contain lies. The first one being actually they're just shorter. Nobody is a good enough liar to come up with as many details as someone who's simply describing reality. Turns out you can also do things like determine the person's age and other characteristics. But one of the really interesting ones is that you can determine whether an email is being written to someone above them in the organization versus someone below them. They use different kinds of words, different patterns of words. So these are the kinds of applications you can do. And lastly, one of the really big areas right now, AI is, of course, a very hot topic, and for very good reason. It's doing really great things, but it's doing things mostly in the area of data, not unstructured text. And so using text analytics, you can enable really, really smart AI applications, because an AI application is only as smart as the training data you give it, and that's where text analytics comes in. So again, that's just a very quick, brief run through. So now we're going to turn to this potential for text analytics is huge, but the question is, how do you get started? How do you get the most value out of it? Or if you've already started, how do you take the, things to the next level? One of the things that we've done with the Text Analytics Forum that I chair is we've done a number of surveys, and one of the things we found was a lot of companies have started text analytics. They've got some software, they get some taxonomies, they get some machine learning, and they try to do it, and they get it up to maybe 70% accuracy, something like that, and then they get stuck. And so this is something that is very common. And so the techniques we're going to describe today can be used both for people that are just starting out, but also for people who want to take their text analytics to the next level. And the new approach, there's two key ideas: content structure models and a mini POC. These are both ways to get people really started or to enhance their current initiatives. And so two of them together provide powerful tools. So let's talk about content structure models. The first thing to remember, we always talk about unstructured text, and the reality is it's not unstructured. Documents have words, sentences, paragraphs, and then beyond that they have things like sections and clusters and other kinds of structure. So polystructure is probably a better term, or semi-structured. And in addition, even things that look like they have absolutely no structure at all beyond, say, sentences, and even there it's a little bit fuzzy, tweets, you can use actually conversational structures to enhance the meaning. And the point is that we don't know what goes on in the human brain right now when people read, but we're getting better and better at that, and we're learning more and more. But one thing we know for sure is that the way people get meaning out of a document is not to strip out all the indicators, not to strip out the headings and so forth, and create a big giant bag of words, mix it all up, and then count the number of times particular words show up. That's not how humans understand meaning. And so content structure models enable you to use the structural indicators that humans use to understand meaning within your text application. Okay, so let's dive into that a little bit more. Content structure models have four basic elements. Number one is content types. They've been around for a long time. People have put a little bit of effort into it, very often when they want very formal documents. Turns out that content types, though, there's a variety of different types, and each one of the types tends to have a different kind of structure: proposals, articles, blogs, and so forth. So content types kind of create the taxonomy of the taxonomic structure for a content structure model. Then on top of the content types, as I mentioned, each content type has a different section structure. And by sections, again, we're defining it very broadly. It includes things like, the title, includes things like an executive summary, methods, objectives. It can even include different changes in font size and header footers. So sections then can be used. Even, for example, really dumb search engines use titles, for example, and they count the words differently in the title. Well, if you expand that idea with these text indicators, that you can use text analytics applications or functionality to capture what the different text indicators are within these various documents. You might see simply the word introduction. It might be the words executive summary. Well, it turns out that there's different kinds of sections. And for example, executive summaries, we did one project where we actually had about 15 different terms that really meant the same thing from a functional standpoint. So you've got content type sections and text indicators, and then you use that to weight the terms within a categorization rule differently depending on where they are in the document. Again, this is the kind of thing that humans do. When you do a full giant bag of words approach, the results are usually very, very difficult to get beyond a certain level. And the reason is because they're not using these kinds of indicators, these content structure models. So once you build a content structure model, combine that with categorization rules, and we've been able to get up to 95% accuracy in a number of different projects. And we'll show you some examples of that as we go on. Okay, so here's an example of a document structure. In this case, for example, the title is in a different font. It's also can be defined by the position in the document. It tends to show up in the first, say, 100 words or so. You've also got sections like what's known on this subject and what the study adds. Those can be useful. The most useful for auto categorization for, say, a search application, what is this document about, are the abstracts. Some sort of abstract. And so in this case, for example, it's called backgrounds and objectives. Well, it functions as an abstract, methods being a different one. And then over on the right, you've got a number of different kinds of sections, some of which you don't really want to pay attention to. Authors, for example, if you're doing an application, well, you might want to grab all the author names, but more often than not, you want to ignore them, particularly when you're trying to figure out what the document's about. Abbreviations, another one that points to something outside of the document usually. And so you want to not pay attention to that. And then there's that little one in the middle, keywords. That's the tricky one. Keywords, asking authors to add keywords to documents, we've been doing that for a long time, and the results are usually pretty abysmal. They don't like to do it. It's not their job. They tend to resist. They tend to do bad jobs at it. So keywords are really problematic when you try to understand what a document's about. Because when you think about it, if someone writes an article, they're some subject matter expert, and they want to try to figure out what are the right words to put in the keyword fields for a non-subject matter expert to figure out what the document's about. And again, so that's a skill, and it can be trained, but most authors don't have it. So we actually have one project where we're building these categorization rules, and we're getting about 70–75% accuracy, and just seemed to be kind of stuck. And then we took out keywords as one of the fields, and accuracy jumped up to 90%. So keywords is one of those sections you want to be careful about. Here's another example from a recent project we're just working on. We'll show you some results of that later. Again, the title is indicated primarily by the font and by the position in the document. And then in this particular case, there's 3 sections of the document you want to pay attention to and weight those words more heavily. And then you've got things like fit with overarching strategy. Again, that points to something other than what's in the document. Collaboration with other teams, same thing. So one of the things that you can use content structure models is to pay attention to certain sections and particularly to ignore a number of other sections. Okay, so before we go on to show you some examples of that, there's one other aspect of content structure models that I wanted to mention, which is you can use them to really empower data extraction applications, which then become a really rich source of metadata. These kinds of extraction applications can be automated or semi-automated. You can add in additional text analytics, categorization kinds of functionality to help resolve disambiguation. Also knowing where to look in the document for particular kinds of data is another use of this. And then fact extraction, which Bob is going to talk about more, is even more powerful, where you're talking about not just, okay, what are all the addresses in this document, but what are the addresses for specific entities? So it's a relationship of entities or the entities in the relationship. So when you do all this, then one of the applications you can do is extract all that data and analyze it, combining internal and external, combining structured and unstructured, and build much richer analytical applications. Okay, so what do you get for all of this work into content structure models, which actually, by the way, don't require a huge amount of work? Well, the real important point is that you're using human judgments about the aboutness of a document. When someone is writing an executive summary or abstract or other types of sections, they're telling you this is what we think is important and this is what you should pay attention to. Well, you can build these kinds of content structure models to empower the text analytics applications to pay attention just to those. And so you get an improved human-like understanding. I thought it was pretty funny when people started talking about deep learning and how it was more human-like. And then they would say, well, yes, and all you have to do is train it with a couple billion different examples. That's not really human-like. Okay, but this kind of approach really is. It enables you also to do more with less. It enables you to get more precision. One of the big problems with looking at a bag of words is trying to figure out what are the different kinds of concepts in here and how do they relate to each other. As I mentioned, it also enables you to do entity and fact extraction. So this is what you get for building a content structure model. Okay, let's talk about the second piece to this. A Mini POC is something we've been doing now for about a year. It uses content structure models, but the idea behind it, see, the whole point of text analytics, it is a complex field. It can be expensive. It can be a lot of effort to get started, particularly if you don't know what you're doing. And so you want to know what you're really going to get. Well, a Mini POC is designed to do that. It's 1 week, 40 hours of effort, and that's it. And what it does is it demonstrates the power of text analytics and how you can utilize unstructured text. And the thing that's so powerful about it is it's not a demo. It's not somebody, because companies can produce some very slick demos that look really powerful and show off the features, show off the application itself, but it doesn't necessarily connect with what the individual that's receiving the demo really has. So what this enables you to do is use real content, real topics, and create something that everybody can understand. So the Mini POC consists of 4 steps. Number 1 is selecting or creating 10 taxonomy categories. So if you've got a taxonomy, select 10 of those categories. If you don't, just 10 major concepts within the field that you're working with. Then the key is then providing 20 documents per category. The documents should be good examples of documents about that particular category. The next step is then to develop a draft content model based on those 20 documents, now a total of 200 documents. Sometimes they all are the same content structure model. Sometimes you've got multiple ones. So this is something that is a very necessary first step. Then the last step is then developing the auto-categorization rules. And this then provides the kind of output you can get where you're providing or getting close to 95 to 100% accuracy in this kind of a Mini POC. So when we talk about categorization rules, it's important to recognize that there's two different parts. You've got the logic. What are the sections? What are the different weights? What are the start and the end text indicators for the different sections? Weights really can be, 0 to all there is. The one example I showed you where we did a recent project, we basically only paid attention to those three sections and the title, and just ignored the rest of the document, and that enables us to get much better accuracy. But categorization rules also consist of a set of terms that indicate the aboutness of a document. And these are the kinds of things that, if you're just building a taxonomy, you look at alt terms and things like that, and those are useful, but they go way beyond the kind of terms you need for really good categorization. If your topic is agriculture, for example, most of the documents about agriculture don't mention the word agriculture or any particular synonym. They might talk about new farming methods. They might talk about other kinds of techniques. And so you have to incorporate all that into your categorization rule. Journal names that happen to be associated with that particular topic is another one, unique methods and so forth. So the categorization rules consist of those two parts. So what I want to show you now is the results from the latest project we did in the Mini POC. We actually did two for this company, so a large foundation. And we explored the different content types, built the content models, and then built those categorization rules. And so one of the things that came out of that is that it was such a success that we're now building an application to retag documents, enhancing the accuracy, but also the consistency. Humans are really good at coming up with something that's fairly reasonable as a tag, for example, for a document, but they're really terrible about consistency. And so this is a way to get both. So what kind of results did we get? Well, here's the graph. Don't worry, we're not going to go into all the details, but we basically have 10 categories on the left. And what we did in this particular case, remember the categorization rule consists of both the logic and the terms. So what we did is we first ran with both logic and terms, got the results, and then we took the section logic out and went to a standard bag of words approach. And these are the kinds of things that happen. Recall, for example, for family well-being went from 95% accuracy down to 75%. And that wasn't even the worst. Nurses and nursing, for example, went from 95% accuracy for recall down to 40%. And you would think taking the entire document into account, recall would go up, but it doesn't because the words that you're really interested in get swamped by all the words that you're not interested in. Then precision is even worse. Family well-being precision went from 100% down to 43%. I mean, this gives you an idea of the power of content structure models instead of just using a standard bag of words approach. And so this is the overall results. With sections, we got 95% recall and 92% precision on average. Using full text bag of words, recall went down to 71%, precision went down to 41%. This is the kind of power you can get building content structure model categorization rules. So what are the overall benefits of this? Well, first of all, as I mentioned, it demonstrates the value of text analytics, but the really key is that it's a real application with real content. And this turns out to be something that drives the enormous acceptance of this approach, because instead of a demo, you're looking at their own content. And that enables you to then appeal to all audiences. They can see these kinds of results. They can actually have something they can play with. So librarians, KM executives, and so forth. It can also be used to uncover issues with the contents and with the taxonomy ontology. So there are a number of differences, for example, between accuracy in some of those categories we're looking at. Well, that gives you actually a way to measure the fuzziness of the categories in your taxonomies. And then lastly, the Mini POC is the start of building the foundation for a full enterprise initiative. And it's a really great start because it gives you both an initial set of content structure models as well as the initial terms. So these are the kind of benefits you can get using content structure models and these Mini POCs. So you mentioned in the beginning, I talked about text analytics as being semantic software and semantic models to analyze text. So today I've been mostly talking about semantic models. So what we're now going to do is shift over to Bob, where he's going to talk about the kind of software using Smartlogic Semaphore that enables you to do these kinds of mini POCs and other text analytics applications. So with that, I'll turn it over to Bob.
All right, thanks, Tom. So as Tom mentioned, Semaphore is a platform used to run the KAPS Group's POCs and full-fledged semantic projects. So basically, Semaphore provides an enterprise 3 broad capabilities. The first is to develop and manage semantic models. Semantic models can be anything as simple as controlled value lists or to more complex types of modeling such as taxonomies and even full-blown ontologies. So it provides the modeling capability for a wide range of semantic models. Secondly, the platform enriches content, data, and information by using classification for tagging, for entity identification, and fact extraction, which I'll talk more about those things in a bit here. And then thirdly, by applying this consistent metadata and semantics to content, that then further enables knowledge discovery, discovering new information, new relationships, new insights into your data and content. It supplies a semantic foundation to improve discoverability, search, and for improving further analytics. And it also provides an automated platform for automating the application of semantics to your content. So those are kind of the 3 broad capabilities that Semaphore provides. So next, where does it fit into the enterprise? So basically, Semaphore provides the semantic layer that fits between your data systems, things like content management systems, databases, etc., and end user systems and applications such as search, business intelligence, which includes reporting and analytics, and also helps power internal and external portals, and other types of user systems and applications. The other thing it does is maintains a consistent set of definitions and relationships between concepts and terminology that is important for your business, and it provides that consistency across the entire enterprise to all the different data systems. The other thing it does is by providing this consistent semantic layer, it gives the business and end users the ability to quickly respond to complex information requests. For example, querying across multiple disparate separated data systems and correlating results in a meaningful way. And then it also gives business users the ability to directly manage the semantics of the data and information systems without the need for IT intervention. So, for example, if you need to supply new values to, controlled value lists for some downstream system, they can all be done within the Semaphore platform by business users, and you don't have to get IT involved in implementing those types of things. Right, next. So I'll dive a little bit more into the classification capabilities, since that's one of the aspects that certainly drives the POCs and the work that KAPS Group does. So there's 3 broad types of classification that we support. The first thing is entity identification. So this is identifying things like people, organizations, places, addresses, things like that. We're able to identify those things in content. The next type of classification is subjective and thematic classification, and this is really what's being used by Tom in the POCs that he puts together. This is the aboutness classification. What is content about? And this is the tagging of content with concepts from a semantic model. So it's a model-based subjective and thematic classification. And then the third broad capability that Semaphore provides is the ability to identify and extract meaningful bits of information from content. So examples include, if you're looking at SEC filings, for example, we're able to identify the target of acquisitions, the dates that are important, principal players and their roles, dollar and or stock amounts involved, things like that. So we can set up a set of rules to analyze specific content types and extract meaningful information. Another good example we do a lot of is product issue analysis. So if you've got a software ticketing system, or in manufacturing, or in the pharmaceutical industry, basically trouble ticket analysis, where we can identify reports of problems, identify what the symptoms are, and what the causes of those problems are. And then again, correlate all of that across all the different issue tickets in the system involved. So it's a couple examples of how to use fact extraction to get insight and additional information out of your data. So next. So, and then specifically how I'll kind of walk through a couple little how we support the KAPS Group's POCs. So first of all, Semaphore provides the platform for modeling the categories that Tom was talking about. And we do this in our tool called Knowledge Model Management. And next. The second bit is providing the platform for creating, editing, and testing the rules that are used to then classify the content. And then the third bit, next, is the actual performing the auto classification. So here's a little screenshot of one of our analytical tools where we test our rules and see how well they're performing against documents. So again, this is an example of performing the subjective and thematic classification. And with that, I'll turn it back over to Tom to summarize what we've gone through today, and then we'll open it up for questions.
Okay, thanks, Bob. That was great. First of all, in summary then, as we mentioned in the beginning, there's no such thing as unstructured text. So it's really a misnomer. And say semi-structure is probably the best way to describe it. And the point is that capturing the content structure of so-called unstructured text is really the key to improving categorization and fact extraction both. And good categorization and fact extraction then is a foundation for an effective search and all the search-based applications that you can build and all the multiple analytical applications you can build by pulling all the data out of text. So semi-structured text is probably still a great untapped resource today. There's some amazing things with data and structured data, but text is still largely untapped in terms of its potential. And then a mini POC using content structure models is really the key to starting or revitalizing the use of text analytics in your organization. It's actually both a foundation and a demonstration. And it's the foundation you can then build on. One of the things we found is that everybody that we've actually done a mini POC for has gone on or wanted to go on to do additional work. And then lastly, Semaphore then provides the tools and technologies to support this whole process. So with that, we'll conclude and we'll open it up for questions.
Thanks, Tom and Bob. Great presentation. So we do have some questions. And as I said before, if anybody has any additional questions, please enter them in the question panel on the right-hand side of your screen. But the first question, Tom, is what is the time and resource commitment from a customer's perspective for the mini POC?
Okay, good question. Basically, the time and the resource commitment is really all about just simply finding 200 documents that are good examples of 10 categories. Typically, that takes a few hours. There's not a whole lot more than that. It's not like you have to find the best examples or the things that really precisely define, just really good categories that are about a particular topic. So it's very, very few hours on the part of the customer. Most of the work is done, actually the bulk of the work, the intellectual work is the content structure model, and then the bulk of the work is actually creating the categorization rules in terms of time and effort, but that's all done by us.
Okay, great. So you refer to a content structure model, and many of us think of ontologies and taxonomies. Is there any difference between the two?
The differences really are what you're modeling, what you're applying to. I mean, there's a whole class of sort of semantic models, and you know, it can include taxonomies, ontologies, and all, you know, knowledge graphs, another way of presenting it. And so basically the difference is that taxonomies, ontologies are really designed around what are the concepts and the relationships between the concepts. And so that's like the framework. The content structure model is focusing entirely on the actual content itself. You know, what is the content within each kinds of documents, or each content type that you have. And so one is content focused, one is concept focused. And the power, of course, comes when you put the two of them together.
Great. Here's one. How deep should the hierarchy be in the taxonomy when you're doing a mini POC? Is it flat? Is it nested?
Yeah. That's a very good question, and actually I'm working on an article right now trying to come up with what are their kind of best ways or best types of taxonomies for text analytics. For a mini POC, it doesn't matter too much because you're not really using the taxonomy structure, the relationship between the terms or between the concepts. And so basically, when you're picking out 10, now we've done some where some of those 10 were you know, second or third level in the taxonomy. But again, for the results of a mini POC, it really doesn't matter too much. Once you go beyond a mini POC and you start looking at you know, building applications, then you come up with the whole idea, the whole notion of what's the best kind of a taxonomy for text analytics. And of course, the best kind of taxonomy is to have concepts that are very highly orthogonal, that are different from the other concepts. So you don't want to have a lot of overlap. You know, so if you've got information security, information management, information tagging, all in your taxonomy, they overlap an awful lot. So you want to try to have very orthogonal categories. For the mini POC, quite honestly, we're looking at the taxonomy's concepts mostly separately, so it doesn't really matter. As long as there's good content to go with it, that we can build these categorization rules from.
Okay. Here's another one. Have you tried to extract and classify data from company annual statements?
Let's see. The short answer is, yeah, we did something like that, but it was a while ago, so I'd have a hard time sort of describing it. But yes, the point is you can pull out text from any format, and as long as you, again, use the content structure model to capture the format, to capture what are the important parts. And so if you're trying to use annual reports, for example, there's the usual two components to that. You know, what are the key concepts in your annual report? And if that may be the subject of the annual report, it may be certain themes within the annual report that that highlight certain problems. So that's part of it. Then the second part is, you know, pulling out the key data, which again, you can use these kinds of content structure models or just fact extraction generally to pull out from that particular annual report. Now, then, of course, very often what you want to do is then compare that, look for emerging themes, look at annual reports over a number of years.
Okay.
Okay.
Bob, did you have anything to add? I don't know.
Yeah, I think on that one, that definitely falls into the category. I'd given an example of the SEC filings. And so, yeah, definitely, and following on what Tom says, is that, you know, there is a structure to annual reports. And so depending on what you're trying to get out of them, you figure out, okay, what are my types of information am I trying to get out of it? And then developing fact extraction rules to identify those bits of information and extract those. So that's definitely something that we've done with Semaphore before.
Yeah. Okay. How can the results of statistical tools be integrated with the semantic text analysis? Have you found that statistics can enhance the performance of semantic analysis?
Yeah, another very good question. When I was talking about the sort of definitions of text analytics, of text mining and text analytics or linguistic conceptual text analytics, there's a lot of people will come down in one camp or another, saying you do this, do that. Text mining is rules, no text analytics. The reality is the trend over the last few years has been, how do you put these things together? And again, there's no simple answer to that, but the answer is yes, you can put them together. In some cases, simply by putting them side by side and having two sets of results that you can compare. In other cases, you can take things like some of the statistical representations and incorporate that into as a filter, say, for example, would be one way of doing it. So there's a number of different ways of putting them together. So like it may be, for example, that one of the mini POCs we were just doing, where we're looking at three sections, but then also the title. And the titles, very short, not a lot of text in them. It turns out you can create a filter that looks at if we know, if we're really happy with what the title is about, and that can be done both with machine learning and linguistic approaches. Then we can use that as a filter or a first pass, or we may, for example, create an algorithm that looks at different weights and puts them all together into one large algorithm. So that's one way of putting these things together. In addition, for specific applications, you may want to build a statistical application that gives you, say, for example, input into building more term-based applications. So, and then the term-based applications also can be used as input as a filter into statistical analysis. Part of the problem with statistical analysis, again, is if you're looking at a bag of words approach, the noise is just huge. And so one of the ways to put them together is to filter first with text analytics, the categorization, and then apply statistical models to it. So it's back and forth. You can do the relationship is a complex one, and it depends on what you're trying to do and what's the best way of putting the two together.
Okay, thank you. This one is for Bob. So there's a lot of hype around graph technologies and graph databases. Can the metadata that comes out of Semaphore be integrated with a graph database?
Yes, absolutely. In fact, the underpinnings of the modeling tool that Semaphore uses is RDF. So it is a triple store. Models are stored as graphs, and output from classification can be done with triples also. So it's very well positioned to integrate with the more modern technologies of graph databases and RDF and semantic web enabled applications. So it fits right in with that.
Great, thank you. I have another question. How successful has this process that you developed, Tom, been for tabular data?
Well, I guess the real answer is it depends on what kind of data you've got. I mean, the tabular data, just if that's the format, you can take advantage of the structure of a table, for example, to incorporate into rules. But if you're talking about just numerical data, then this doesn't really apply to that directly. I mean, you can. It does in a sense when you're doing entity extraction, but not otherwise. So yeah, I guess if we're talking about tabular data or table based, it's something. If there's text in there, this approach works, but it's really designed around text, not numbers.
Okay.
Yeah, I'll jump in a little bit on the Semaphore side of that. So we, within our rule structure and rule framework, have rules that we can target tables to help extract information from tables, using, column headings and rows. So that's something that Semaphore supports. I also wanted to just add a little bit more to the question about statistical versus semantic analysis, and really agree with what Tom said. You don't want to fall into the trap of either or. They both provide different types of values, and I think as Tom was saying, that positioning them together or one before the other, depending on your cases, is a really powerful combination. And I know, working with a lot of customers and working with technologists, they tend to latch on to one approach to solving a problem, and it becomes the end all and be all. But from the business perspective and what problem you're trying to solve, you don't want to get trapped into this versus that. You want to focus on what problem are you trying to solve and apply all the tools that you can to solve that problem, and not get caught up in the the technology wars of this versus that.
Okay, I don't see any additional questions. Give everybody.
Actually, let me add something also to that. Then to an earlier question, the question about, for example, the amount of effort in terms of the organization that's doing the Mini POC. As I mentioned, it's typically a few hours, and that's about right. It's been the case pretty much throughout all the ones we've done. But one of the things that, mostly it's just sort of looking at a document. If you've got somebody that's a subject matter expert, you can say, yes, this is it. And one of the sort of tricks or techniques that we use to then speed up the development and the testing of the category is, and this is something either the client can do if it's straightforward, or we've got some automated processes that can do it as well, which is to incorporate the category name into the file name. Doesn't sound like a lot, but actually it can save you huge numbers of hours when you're trying to refine categorization rules. So the thing to remember about categorization and these kinds of applications, they're not like a lot of data applications where, or a lot of program applications. Does the program work or not? In text analytics, is how well does it work? It's an iterative process. You have to you have to go through a process of refining the categorization and getting it better and better. It's not like you're done, or it works or it doesn't work. You can set certain levels and say, okay, we're going to only be satisfied with 90% accuracy, but it's something that it's an iterative process to develop these kinds of categorization rules. Once they develop and become mature, then no, you don't have to keep constantly refining them. But that iterative process is something to remember about text analytics in general.
And maybe just a follow-on question to that, Tom. Not necessarily the level of effort, but is there any particular skills, like any subject matter experts, business users? What role in the organization does the person play that works with you?
Yeah, that's a good question too, and then the answer is, well, it depends. We've seen a lot of ranges. We've done somewhere it's a marketing expert that knows the company well. In other cases, knowledge management person with subject matter expertise. The subject matter expertise side of it, it's not like you need somebody that can dive in and understands the taxonomy really well and the content and so forth. It's actually, it starts out simpler than that. And so we've done them ranging throughout. One project was for a large technology company, and that was basically a person that was on the IT side, but had been working with a search application. So there's no special training you need to be able to pick out 20 documents. And in lots of cases, actually, there's one case where they just asked us to here's a bunch of our content, go in and pick out some good examples, and so we did.
Okay, great, thank you. I think that's all the questions I see. I want to thank, and Bob, any parting words of wisdom you'd like to leave us with?
No, I think we've covered everything we wanted to, and good questions, and hopefully the answers help provided guidance for folks.
Sounds good. Thank you. Thank you, Bob and Tom, for your time and your expertise. And thank you, everyone who joined us today. As I mentioned at the beginning, you'll receive the link to the recording sometime tomorrow afternoon. And with that, I wish everybody a good day and a great upcoming, for those of you in the US, a great upcoming long Memorial Day weekend. Thank you.
Yep. Thank you, everybody.
Thanks.